Right, this is the Wonderful Skills Homework 13. Length, area and volume. Lots of marks lost in exams looking at length, area and volume. So when we start to look at the questions and convert various things into various other things. Okay. 1.5 centimetres. We generally don't like using centimetres, but it's on our rulers. You can see the centimetres there, the big numbers. Millimetres are the small divisions there, so 10 millimetres equals 1 centimetre. So 1.5 centimetres to millimetres, so 1.5 times by 10 equals, so calculator, we should be able to do this in the head, but we'll just double check on our calculator. 15, so 15 millimetres. And it's actually easier to convert our millimetres now into micrometres, because now we're into the 1,000 factor each time. So to convert that into micrometres, it's timesing it by 1,000, because there's 1,000 micrometres in a millimetre. So times it by 1,000, that's now 15,000 micrometres. And nanometres, it's times it by 1,000 again, which is a crazy number, 15 million. And that's nanometres. So you should be able to convert between our main units, whether it be grams, meters or whatever on there. And here we are, just started with micrometers. There's no centimeters this time, so it's okay. So how many millimeters are there in a micrometer, or how many micrometers are there in a millimeter? Well, there's 1,000 micrometers in a millimeter. This number for millimeters is going to be smaller than our micrometers. That's the sensible thing to do. So if it's going to be smaller, then we need to divide it. So we're going 120 divided by 1,000, which will give us our millimeters. So that's 120 divided by 1,000 is 0.12 millimeters. And if we were doing it the other way, nanometers, well, there's going to be more nanometers than there are micrometers, so we're going to times that by 1,000. So 120 times by 1,000. So 120 times by 1,000 is 120,000 nanometers. Convert our smallest unit, the nanometers, to the others. Well, there's 1,000 factor between nanometers and micrometers, and then there's another 1,000 going up to millimeters. So actually, all we have to do is divide our number there. So for micrometers, 2,400, we're going to divide it by 1,000. So 2,400 divided by 1,000, which is our 2.4 micrometers, which is like a U but the stalk on the other side. And if we are going to do that again, we are going to divide it by another 1,000, which gives us 0.0024 millimeters. So, and this will be our original number divided by 1,000, and then divide that again by 1,000, or divide by a million. Calculate the area of a rectangle. Let's move over here now, shall we? So calculate the area of a rectangle. 7 by 17. 7 by 17. So area equals length by the width. So 7 times by 17. 7 times by 17. 119. So 119, but what are the units? the units are micrometers, but this is squared because it's area. So that's our answer there. Question 5, I might just change colours for this. Calculate the area of a circle, radius 0.25, 0.25 there, so this distance there, 0.25. The diameter would be all the way across, the radius is halfway across. Using pi is 3.14, so area equals pi r squared equals 3.14 times by 0.25 times by 0.25 equals, and can you see what I've done there? I've written out what I'm doing, I've copied the equation across, I've put in my numbers, I've substituted, and now I'm reaching for the calculator. If you just reach straight for the calculator, you quite often will have an error, and you can't figure out where you've gone wrong, and neither can the examiner, so they give you nothing. 3.14 times by 0.25 times by 0.25 is this number here, 0.19625, and doesn't tell us to give it any particular level of precision. I'm going to because we are given 3.143 significant figures, and that's a sensible thing to give it to. So 0.19, is it 6 or 7? It's going to be 6 there. The area is squared, but what were our original? It was in millimeters. So millimeters squared, and that's our answer there. Question 6. Oh dear me. The volume of a cylinder. The volume of a cylinder. There's my cylinder. Pi r squared h. So h is the length or the height. Okay. And we've got pi r squared, which is the area that we just worked out there. And so r is half of that diameter on the end. So the diameter is all of it, r is half of it. In an experiment to collect oxygen in photosynthesis, blah blah, a tube for 1 minute and 5 millimeters of oxygen. Oh, okay. Well, we got 5 there then. So 5 millimeters long of tube, so 5 millimeters. Diameter was 0.5 millimeters. Aha! Radius. We need the radius for this, so radius will be half of that. So the radius is radius equals diameter divided by 2. 0.5 divided by 2 is 0.25 millimeters. So we've got our h, we've got our r, and we've got our pi. So let's put this into our equation. Pi r squared h equals 3.14 times by 0.25 times by 0.25 times by 5. Hopefully that gives us our nice answer. 3.14 times by 0.25 times by 0.25 times by 5 equals 0.98125. Give your answer to 2 decimal places. Yes sir. 0.9, is it going to be 8 or not? It's going to be 8. There we are. And we're not going to forget our units. This is a volume, so it's going to be our units cubed, and everything was in millimeters. Millimeters cubed. That was question 6. Question 7. In an ecological investigation, they can be fun. An ancient woodland, what the hell is a hectare of woodland contained 211,500 bracken plants. Ferns. Here we go. A hectare is a unit of area 100 by 100. So a hectare is an area which is 100 meters by 100 meters. Okay. How many bracken plants are there per meter squared? Well, in a hectare there's that many, but how many meters are there in a hectare? Well, there are 100 meters times by 100 meters, so a hectare equals 100 times by 100 meters. 100 times by 100, 10,000. 10,000 meters squared. That's what a hectare is. And the information we're given is 211,500 plants per 10,000 meters squared. So now the question wants how many there per 1 meter squared. Well, let's turn 10,000 into 1 by dividing it by itself, 10,000, and we need to do the same by this other side as well. So it'd be 211,500, so 211,000 divided by 10,000 equals 211,500 divided by 10,000. 21.15. 21.15. Does it tell us about any decimal places or rounding off or anything like that? Nope. And so 21.15 plants per meter squared. Or you could write it out per meter squared. Okay. Question 8. Oh, we're getting near the finish now. The volume of blood in the average human is 4 dm cubed. How many cm cubed is that? 4 dm cubed equals 4 litres equals 4,000 cm cubed. They're all the same thing. But, oh, okay, how many cm cubed? We've done it. There we are. So you should just know how many cm cubed are in a dm cubed, especially if you do chemistry, because they use dm cubed quite a lot. But the actual calculation will be times by 1,000. So 4 times by 1,000. We'll move on from there. So I want to put the kettle on. Pond water contains an average 8 bacteria per microliter. Right, there's actually a little mistake on this. I was supposed to proofread these, and I have mucked up. There we are. 8 bacteria per microliter. So that would be -1 there, or per microliter. If you drank 200 cubic centimetres of pond water, how many bacteria would you get? Well, we need to know how many microliters are there in 200 cm cubed. So there are 1,000 microliters in 1 cm cubed, and we've got 200 of them, so 1,000 times by 200 equals 1,000 times by 200. 2 with 1, 2, 3, 4, 5 zeros. So that's 20. Oh, no, it's 200,000. Sorry, 200,000 microliters into 200 cm cubed. So 2,000 microliters in 200 cm cubed. So now we're absolutely fine. So we just need to go, right, well, there's 8 bacteria in each of those. So we need to times that by 8 now. So our 200,000 times by 8 equals that very large number there, which is 1, 6, and then we've got a bunch of zeros. 1, 2, 3, 4, 5 zeros after that. So that's 1.6 million, or 1,600,000 is 1,600. If I space it out like that, okay. And our final use is bacteria. How many bacteria? That's it. That's how many bacteria. So the answer is 1,600,000 bacteria. We got there in the end. And the last one. Anyone ready for a cuppa yet? The diameter of a field of view of a microscope is 18 stage divisions. So we got that there, and then we've got you're looking at your stage. There we are. And we've got 18 of them. Okay, so 18 stages, and each one is 0.1 millimeters. So what's the actual distance? Okay, so we've got so each stage unit equals 0.1 millimeters, and I've got 18 of them. So 18 times by 0.1 equals, you should be able to do that as a tenth. So a tenth of 18, so 1.8. So that's our conversion there, and then it goes, what's the area? Well, you know the area by now. So the area equals pi r squared. So 3.14 times by our radius. What's our radius? that's the length. So radius equals half of that. So diameter divided by 2 is 1.8 divided by 2 equals, should be able to do that in your head as well, 0.9. So 0.9 times by 0.9. So that's our area. So 3.14 times by 0.9 times by 0.9 is that number there. 2.54. What's the units? Millimeter squared. So that's the area. What is the area? So that's our first answer. I'm going to underline that. And then we've got 200 stomata in that area. How many there per 1 millimeter cubed? So we've got 200 stomata in 2.54 squared millimeters. So again, we're going to convert 2.54 to 1. So divide by itself, and we're going to do the same to the other side. So 200 divided by 2.54 equals, so 200 divided by 2.54 is 78.740 blah 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 blah. But all of this stuff is in two significant figures, or 2 decimal places, on average. So that's a sensible way to express it. Does it give us any instructions? No. So we're going to have that. Units, stomata per millimeter squared, and I'm going to put minus, which means the per. And I've just got enough space to underline that. I'm glad there's no more questions.